in this video, we're going to get some more practice with the factoring by grouping technique. So our directions here are to factor the following polynomials by grouping. So in this first example, we have y cubed minus 7y squared plus 3y minus 21. The first thing I notice is that there are no common factors that I can pull out of all of those terms, right? The last term is a constant. The first term doesn't have any numbers to it. So I'm just going to begin factoring by grouping. So I'm going to group the first two terms and the last two terms. So I've got y cubed minus 7y squared in one group and 3y minus 21 in the other group. Okay, so in the first grouping, y cubed minus 7y squared, I can pull out a y squared, right? So then what do I have left over? Y squared times y is y cubed, right? And minus 7 times y squared is minus 7y squared. Okay, so now that takes care of the first grouping. Now in the second group, I have 3y minus 21. Well, let's look at the numbers there. 3 is common to the first term and also to the second, right? So I'm going to pull a 3 out. And what will be left? 3 times y is 3y, and 3 times negative 7 is minus 21. Okay, now I look at this expression, y squared times the quantity y minus 7 plus 3 times the quantity y minus 7, and I notice that y minus 7 is common to both of the terms, right? So I'm going to pull out y minus 7, and what will remain is y squared plus 3. So fully factored, we have the quantity y minus 7 times the quantity y squared plus 3. Okay, so let's check this. Now, if you're really comfortable with foiling, go for it. I'm going to show you another quick method that sometimes it's almost easier to do this to just make sure that you've got all of the terms of your original expression present. So you can kind of think about it like when you find the area of a rectangle, you've got area equals length times width. So we can think of one of these as y minus 7 and the other one as y squared plus 3. Y squared times y is y cubed. Y times 3 is 3y. Y squared times negative 7 is minus 7y squared. Negative 7 times 3 is minus 21. Okay, so all of those terms, the y cubed minus 7y squared plus 3y minus 21, it's all in there with what the original expression was, right? Okay, so sometimes that's a quicker way than trying to work out all the foiling. And it's a method that we may use. You can also just simply FOIL it. It's just a matter of when we multiply it all out, do we get what we started with? To this next expression, x cubed plus 4x squared minus 2x minus 8. Okay, so again, always look for a GCF among all four terms, but there isn't one in this case, right? The last term doesn't have a variable, and the first term doesn't have a number, so we can't do that. But we can group the first two terms, x cubed plus 4x squared, and we can group the last two terms. Now, be careful. If you're subtracting that 2x and I put a parentheses around those last two terms, you got to think about that negative as being distributed through those last two terms. So change the sign on that 8, right? So when we distribute the negative through, we have minus 2x minus 8. Okay, careful with that. The negatives can be tricky business. All right, now in the first two terms, x cubed plus 4x squared, I'm going to factor out an x squared, right? So I'll be left with x squared times the quantity x plus 4, right? Since x squared times x is x cubed, and x squared times 4 is 4x squared. Now we're going to move on to that second grouping. So we have a minus there, but then we have 2x plus 8. So between 2x and 8, 2 is common, right? So I'm going to pull out a 2, and I'll be left with x plus 4. Yeah? And again, when we do that distribution back through, you're really distributing the negative 2. So you have negative 2x minus 8, which is what we started with. Okay, now I'm going to yank out an x plus 4, factor that out from both of those terms, and what are we left with? X squared minus 2, right? If you like my little rectangular method, you're welcome to just FOIL. I mean, that's all you're really doing here. But this one is good because you can see it's sort of foiling with a little better visual, right? So you have x plus 4 on one side and then x squared minus 2 on the other. Okay, x times x squared is x cubed. 4 times x squared is 4x squared. X times negative 2 is minus 2x. And negative 2 times 4 is minus 8, right? So all the terms in those little boxes are terms of the original expression, right? If we were to add them all up, it's the same thing. Okay, so moving down here to t cubed plus 4t squared plus t plus 4. Again, no common factor we can pull out, so I'm simply going to group the first two terms and the last two terms. Okay, in the first two terms, t cubed plus 4t squared, I can pull out a t squared. And then remaining will be t plus 4, right? Since t squared times t is t cubed, and t squared times 4 is 4t squared. Now, what can I pull out from t plus 4 in that second grouping? Well, nothing, right? Now, in this case, you want to remind yourself there's like a little imaginary 1 out there, yeah? So when you factor out the t plus 4, which is still common to both of those terms, then the 1 remains, right? So the leftovers are t squared plus 1. And that plus 1 is really important because without it, you would just be distributing t squared through t plus 4. But you don't want to do that, right? You want to FOIL all of that out, right? So when we check it here, we have t plus 4 on one side, and we have t squared plus 1 on the other. T squared times t is t cubed. 1 times t is just t. T squared times 4 is 4t squared. And 4 times 1 is 4, okay? Again, if you add up everything in those little boxes, you get t cubed plus 4t squared plus t plus 4, which is the expression that we originally started with. So keep in mind this 1, right? When you can't factor anything out of one of the groupings, that's really important to leave there when you factor out the binomial. Okay, so now let's take a look at this next one. 6xy minus 15x minus 14y plus 35. Okay, so again, I'm looking at all of the numbers, 6 and 15 and 14 and 35. 6 is not common to any of them. And we know if we do have a common factor among the numbers, it has to be less than 6, right? Well, what are factors of 6? 2 and 3. 2 is not a factor of 15 or 35, and 3 is not a factor of 14. So I don't think we have any common factors, and the last term doesn't have any variables in it. So let's, once again, do the factor by grouping. Now, careful here, because of that minus 14y in the middle, when we do that second grouping of the 14y plus 35, we actually have to change this plus 35 to a minus here, right? So when we distribute the negative through, we get minus 14y plus 35, right? Because a negative times a negative is a positive. Okay, so now let's start with factoring the GCF out of each of these groupings. Okay, so starting with this first grouping, 6xy minus 15x. Amongst the numbers, I notice that 6 is not a factor of 15, but 3 is, right? 3 is a factor of both 6 and 15, so I can pull out a 3. And if I look at the variables, both of the terms have an x in them, right? So I can pull 3x out of the first two terms, and I'm left with 2y minus 5, right? Since 3x times 2y is 6xy, and 3x times 5 is minus 15x. All right, now moving on to the second grouping, got a minus there. With 14y minus 35, 14 is not a factor of 35, but 7 is, right? So I can pull out a 7, and I don't have any variables to pull out there, right? So 7 times 2y is 14y, and 7 times minus 5 is negative 35. Okay? Or I might want to say that actually negative 7 times negative 5 is positive 35, because that was what our original expression was. Okay. So now, what's common to both of those terms? Well, 2y minus 5, right? So I'm going to pull out 2y minus 5 from both of these terms, and I have 3x minus 7 that remains. Okay, so to check this, again, foiling works too. Just showing you another method here. So if I've got 2y minus 5 on one side and 3x minus 7 on the other, 3x times 2y is 6xy. 3x times negative 5 is minus 15x. Negative 7 times 2y is minus 14y. And negative 7 times negative 5 is 35. Right? So when we multiply those two together, we get 6xy minus 15x minus 14y plus 35. Okay, now in this last grouping we have 2x squared plus 10xy plus 3xy plus 15y squared. Now, it looks at first glance like maybe there's something we can pull out of this, but I kind of don't think so, because the highest thing we could pull out with the numbers would be 2, and 2 does not divide 3 or 15, so that's out. We have some x's and y's, but we have the first term with only an x squared and the last term with only a y squared. So we don't have any common factors that we can pull out here. So I'm going to group the first two terms and the last two terms. So I have 2x squared plus 10xy in the first grouping, and 3xy plus 15y squared in the second. And we're adding everywhere, so that makes it easy. Okay, so in the first grouping of 2x squared plus 10xy, I see I can pull a 2 out, right, since 2 divides 10. And I also know that x is common to both of them. So I'll have 2x times x, right, that'll give me the 2x squared. And 2x times 5y will give me 10xy, right? Okay, here we go. All right, so that takes care of the first grouping. And in the second group, between 3 and 15, 3 is a factor of 15, so I can pull out a 3. And I notice that y is common to both of those terms. And so 3y times x is 3xy, and 3y times 5y gives me 15y squared. So we've got a lot going on here with the variables, but remember you've really got two terms, right? 2x times x plus 5y, that's one term. And then the other term of 3y times x plus 5y. All right, so x plus 5y is common to both of the terms. So I'm going to factor it out. So I have the quantity x plus 5y times the leftover of 2x plus 3y. All right, now to check it, I'm running out of room here. In my checking of the other examples, I got used to using this little box method, right? Finding the area of the rectangle. And I'll do that here in a second. But just what that does, that box method does, it really just foils it. It's multiplying every term in the first quantity by every term in the second quantity, right? So I'm going to have x times 2x, which is 2x squared, right? X times 3y, which is 3xy. 5y times 2x, which is 10xy. And 5y times 3y, which is 15y squared. Okay, so I just want to kind of make that statement that in multiplying every term in one of the quantities by every term in the second, you get the same thing as using this little rectangle method that I was using here. So my final factorization of x plus 5y times 2x plus 3y. 2x times x is 2x squared, right? 2x times 5y is 10xy. 3y times x is 3xy. And 3y times 5 is 15y squared, right? So all these little terms in the boxes, if we add them up, we get the original expression. And it accomplishes the same thing as the FOIL method. Okay, so again, this factoring method, it only works on special polynomials that have 4 terms. This method can also be helpful to us in factoring trinomials once we know what we're doing with it. So that's what's coming.